Welcome, this is APS203. So I'm going to start with the iceberg analogy, right? I love using this iceberg analogy for lots of different things. It's a really, really powerful metaphor, a great metaphor for not being able to easily see the bigger picture or not being able to see the things that remain hidden until too late. So we're going to talk about it today in the context of vulnerability management. So the tip, everything above the waterline, that is what we see running in production. Those are our servers, those are the things that are customer facing, those are our running workloads, and beneath the surface, that's where the real challenge is. That is everything that makes up the applications that run, makes up the servers, makes up the infrastructure. It's our code repositories. It's the dependencies that our developers are using every day. It's a number of rapid changes that are going through our release cycles that have to happen in order to be able to see the tip of the iceberg. But also within that, those are the hidden risks that we often have or we often miss until they become major problems. So think about this, and this may be familiar to you, right? It's Monday morning. Your development team is just about to push a major update. The business is super excited. It's something that's been in the works for a number of weeks. Your customers are waiting for it, and you're just about to hit that big red deploy button into production. But all of a sudden, you get a notification about a critical vulnerability, and you have a decision to make. Do you delay? Do you push that big go button into production? Do you accept the risk and figure it out later? And that's the constant tug of war that the business and security are constantly going through. Right, the business wants the development teams to speed up, they want to be agile, they want to allow for innovation. And the security teams are there to protect the organization from undue risk and from undue exposure. They're trying to help the development teams do the right thing, but there's always kind of that friction. And really what we want to be able to do is we want to be able to allow our developers some freedom, allow them to do the right things, but do it in the easy way. We want to empower our developers. And we want to give security teams the visibility that they need to make the right decisions and to help the business move fast and to stay agile. So I'm Danny. I'm a senior security specialist with AWS Industries. What I do on a day-to-day basis is work with our customers, figure out what their problems are, what their blockers are, but also take their feedback. And we'll talk a little bit more about what that looks like on a regular basis a little bit later. And I'm joined here today with Nirali. You want to go ahead and introduce yourself?
Nirali Desai. I'm the product manager here for Amazon Inspector, and I am actually responsible for making sure that we build what our customers need in order to maintain their security of the environments. We'll actually, between Danny and I, will actually take you on how do you expand your vulnerability scanning across your software development lifecycle, all the way from compute to cloud. Quick thing about Amazon Inspector before we get into the details. It is one of the security services with AWS or Amazon. We are an automated vulnerability management service that continuously scans your workloads on AWS for software vulnerabilities and any unintended network exposure. We actually continuously scan all the resources that you may have, such as EC2 instances, the images stored in ECR, Elastic Container Registries, or your Lambda functions. And clearly, we are here to talk about what's new. But let's do the journey so far, just so that we can anchor ourselves on what's been happening with Inspector at scale. When we launched in 2021, we started our journey with protecting all your EC2 instances that needs continuous monitoring and management for vulnerability detection. We added the images to be scanned to detect these vulnerabilities in ECR as well. After that, in 22, we actually expanded the coverage by protecting the Lambda functions. As and when they are detected, you can go ahead and scan for third-party repositories, third-party dependencies, and understand where the vulnerabilities lie. We realized that just third-party softwares is not enough. For your Lambda functions, we expanded to go deeper to add scanning the first-party code that you're running on your functions as well. In addition to that, for your Linux-based EC2 instances, we went deeper by introducing deep inspection. What that means is, so far we were looking at operating system level packages to detect vulnerabilities. With deep inspection on your Linux-based EC2 instances, we also added application programming level packages and understanding the vulnerabilities associated with that. Deep inspection actually is enabled by default on all the new accounts that you may have starting 2023. In addition to that, so far for EC2, we were leveraging SSM agents that were managed by Systems Manager. We were leveraging SSM to extract the metadata, map it to our vulnerability database, and then generate findings based on your environment. We learned that not all instances can be managed by SSM, or you may be in the process of actually migrating into AWS to have SSM installed. So we introduced a hybrid scan capability, which is again turned on by default and is recommended. What does that do is wherever possible, if SSM is installed, we will go ahead and scan your instances using that. And where not deployed, we will just go ahead and scan, fall back to agentless scanning. The deep inspection capability is available on both of them, and you'll be able to generate findings across the board. Clearly, that was not enough. We needed to start early. We heard from our customers that they needed an ability to actually scan these images in their build before they hit production, before they're actually pushed into ECR. So we actually deployed plugins and made them available in the third-party marketplace, such as GitHub Actions, Jenkins, TeamCity, Code Pipeline, so on and so forth, for your developers and you to use in your build pipeline, scan and generate findings, understand what the vulnerabilities lie. All of this actually comes together to generate an understanding of how vulnerable your instances are through a vulnerability database that is managed and maintained by Amazon Inspector. We have MITRE ATT&CK TTPs, CISA's known exploit databases. We also have our intelligence, internal AWS intelligence, security research, security best practices. All of that combined with 50 plus feeds, vendor feeds, CVE feeds, et cetera, combined that actually powers the vulnerability database to generate a composite inspector risk score. That's not just a CVE score, but a composite inspector risk score that tells you how critical that vulnerability is. Tying that with network reachability, for EC2 instances, let's say, we verify if your instance is vulnerable. Is it even reachable from the internet? Has there been an active exploit outside in the world? Is it exploitable? And all of that puts together as an inspector score. We'll continuously discover as and when new instances are brought up, your EC2 instances, new images are pushed, or Lambda functions are initiated, and would also scan when a new vulnerability is detected in our database that may impact your specific resource to generate a finding automatically without you taking action. These findings certainly can be consumed on Amazon Inspector for you, or you could send it out to Security Hub for further processing where you ingest all other findings, or Event Bridge and other northbound connections for you to automate your workflows. Let's look at the top use cases. We'll quickly discover these zero-day vulnerabilities without any action driven by you for all the compute workloads, therefore providing you the vulnerability information in real time without any manual overload. Prioritizing your patch remediation. Now imagine if you actually just had the CVE database giving you the severity level. You don't know if this is exploitable, you don't know if it's actually reachable. How do you prioritize all these findings? So the way we actually compute this with 50 plus vulnerability feeds, mapping that to the heuristics that we use to verify whether these are reachable or not over the internet, mapping that to exploitability kits, malware exploit kits available for these vulnerabilities, improves or adjusts the risk scores for these vulnerabilities, allowing you to prioritize the patch remediation for these vulnerabilities. Our customers have evolving compliance requirements as they are expanding globally into various different geographies or various different industry verticals, and the compliance needs are changing. We offer them an ability to actually meet their audit and compliance requirements as well. Things such as cybersecurity frameworks with NIST, CSF, standards like PCI DSS, the CIS benchmarks. All of these assessments are available through inspector scans. And last but not least, our customers use us today to actually shift left earlier in the development lifecycle. They embed the vulnerability scanning that is available or export the SBOM, which is a software bill of material. It's no different than a nested tree of what the dependencies look like for all my resources for their monitored purposes. Having said that, it's not enough. So let's hear from Danny. What else is our customer telling us?
So this is the best part of my day, right? We talk a lot about working backwards. If you were at the keynote on Tuesday, Amy spoke about customer obsession, right? And this kind of really is a theme that is so prominent throughout my day job as a solutions architect with customers that it's worth talking about for a little bit. And so here at AWS, we're obsessed with working backwards from our customers, right? What I do is I work with them to help them define and get through architectural blockers, understand regulatory environment, how that may change some of the decisions they have to make from an architectural perspective, but also helping them decide what are the right tools that they can be using in order to accelerate both their development teams, their security teams, their GRC teams, and so on. And so, this customer obsession, you may have heard of it, it's one of our leadership principles. And there's a specific requirement that we keep hearing from our customers. And it really helped to influence why we started to build some of the functionality that we're going to be talking about. So we're going to talk a little bit about what that was. At a high level, this is the requirement. You want to be able to build the applications that are secure, that are compliant, that you can deliver at speed with low friction, but also maintaining high confidence and making sure that the application and all that makes up the application meets your security bar. Sounds fairly straightforward, but there are some complexities to this, so we're going to break it down. First, we have to define what application means. A lot of modern cloud applications these days are more than just your application code. It's made up of infrastructure. It's made up of networking that connects all the things together. Really importantly, your identity and access management policies within your applications, how you're managing your role-based access control, both in the application, but also connecting to other applications. A lot of that connective tissue that's made up of that. How do we define secure? How do we define compliant? These can mean very different things to lots of different customers. But whatever the meaning is, typically it starts with the code. That's where we want to start. That's our root of all of these things. And the more that we can improve the security health of the code that gets written, the more likely we are to help meet this requirement, regardless of which framework, regardless of which regulatory compliance needs you may have. And really, we want to answer, is the code that's being written by the developers aligning to these security best practices? How can you validate that? How can you attest to that? How can you assure that you're following that as well for when it comes to audit time? Deliver at speed. How many times in a day do you think development teams are getting told by the business that they need to move faster? That they're under time pressures, that they want to be more agile, be quicker, more release cycles, no more delays. This translates to a very high number of sprint cycles, a very high number of releases, much shorter time in between those releases, all while trying to balance the secure and the compliant requirements from before. We add on top of that, low effort. We want the application, again, which is made up of all of those things, We want it to be secure, we want it to be compliant, we want it faster, and we want it with low effort. Sounds like automation, okay? But then, on top of that, and finally, we want the whole thing to be able to be done with high confidence throughout. Maybe it's for audit purposes, maybe it's for risk, maybe it's for repeatability. But either way, you want to make sure that what you have can be repeated and there's a high confidence in the security bar for the application and that you're not slowing down the business. So not asking for too much. So we talk about the business requirement, right? The need to build secure and compliant applications while maintaining speed and confidence, which is great. But what we want to do is we want to zoom in on where this actually happens, which is the developer's workflow. We know that the cost of fixes gets exponentially higher the further right this line that we go. If you're identifying patches in your running workloads, it's going to be much more expensive to fix than if you identify good mitigations or good controls early in the planning and design phases. So ideally, as early as in planning and design, we're doing things like threat modeling. We're working with our security teams to define secure patterns, secure constructs, baseline controls that development teams that can easily consume, and so they're already starting on the right foundation. And as Nirali had spoken about, Amazon Inspector has been moving left over the years. Right? At the beginning, we started very far right with the monitor and respond with things that are running in production on your EC2 instances. But now we have these integrations into our CI/CD pipelines with things like native integration with code pipeline, but also additional plugins for other providers like TeamCity and Jenkins. But here's the thing, it's still not enough. You're asking us to do more, and the earlier we can catch these issues, the better it's going to be. We want to get as far left as possible, right where the code is being written. Who remembers Log4j and Log4Shell? Lots of people. And I want to highlight this just as a way to talk about why shifting left is so critical. This graph shows the monthly downloads since January 2022 of vulnerable Log4j packages. If anyone remembers their history, this came out in December 2021. So even knowing about this, the number of downloads continues to go up. We might think it's old news, we might think Log4j is in the past, but actually, the data is telling us otherwise. About 30% of Log4j downloads today are still vulnerable versions. And so it's really hard to understand that, right? Organizations are still unknowingly pulling in these dependencies without truly understanding that. And again, if we identify a vulnerable Log4j package in production, that becomes much more expensive to fix than if we identify it early. But we know also that this can get more complicated. You may be relying on a third-party package, and that third-party package also relies on a vulnerable Log4j. How do you know that? We need to be able to identify that, and we need to get visibility into our code and dependencies early in the development process in order to catch these issues before they become a bigger problem in production.
And that is why we're introducing Amazon Inspector Code Security. Build your applications faster and securely, all the way from code to cloud. Today, we're thrilled to share this new capability that allows you to expand the continuous vulnerability management from your AWS compute resources to now scanning code repositories in GitHub or GitLab platforms. Let's see what the core capabilities of code security means. First, software composition analysis. This is something that we've actually fundamentally done for your compute resources on Lambda functions, images in ECR or EC2. It helps you scan and identify vulnerabilities in third-party dependencies, libraries, open source packages that you may be using in your code. The same capability now expands to your code in the code repositories in GitHub or GitLab. We also know that not all your code is just open source. Your developers write your own proprietary code. And protecting that and identifying the vulnerabilities in those early is also equally important. So with static application security testing scan, or SAST scans that we all know, you're able to get visibility into the security of the code that you write or your developers write to identify issues such as hard-coded secrets, injection flaws, weak cryptography, so on and so forth. Further, we know that you actually use code to deploy your infrastructure and scale. You've told us that you use CDK, Terraform, CloudFormation to actually scale all the infrastructure on AWS and beyond. How do you proactively identify any misconfigurations in your infrastructure as code if you didn't scan them early? So adding infrastructure as code, or IAC scan, as part of one of the core capabilities in code security. This will allow you to identify any of the risks early on, misconfigurations early on in your IAC templates, and significantly reduce your risk as you scale your infrastructure. And with that, we now move further left into your development lifecycle, starting where your developers are editing the code in your source code management, and identify these issues earlier, reducing the risk, reducing the mean time to resolve, making these issues cheaper to fix early on before they actually make it to production. But I often wonder, when we do these as security personas, what does a developer think? Do they come along in that journey? Danny, what do you think?
This is the issue, right? Typically, no. Most organizations at the moment still have a pretty distinct governance model and detached governance model between their developers and between their security teams, right? We talk a lot about DevSecOps, and we talk a lot more about alignment between these two. But at the moment, developers still have a lot of, let's call it, unfettered freedom in the sprints. What they then get at the end of that sprint normally is a very long list of vulnerabilities and things that they need to go do from a security organization. Usually happens at the very end of that sprint before they're about to hit go. And they then need to go and spend a lot more time to go and fix those things. Security tests come back, they need to go do some more patches, some more updates and so on, right? And there's a lot of this back and forth. That takes time. Where we want to get to is the developers having a lot more freedom, but within set defined guardrails that the security teams can start to define, but also giving our security teams a lot more visibility across all the repositories, being able to identify which of my repositories are running production workloads, which of them have potentially sensitive data running in those applications, which ones are important to me. So then I can understand as a security person where my risks are and be able to prioritize those a lot more effectively. So what we want to do is we want to move the security team away from this traditional culture of no into a culture of yes, but within more defined guardrails. And fundamentally, this is a step that you can take to start allowing for enough of that flexibility to move fast, to adopt new technologies, whilst making sure you're giving enough and sufficient visibility to do that within risk appetite. And because we know how important this is for the developers, and we know that developers don't really want to have to get out of their traditional workflows, their GitHub environments, their GitLab environments, their IDEs, in order to go and fix security things, we are creating a meet you where you work approach. We want to be friendly to both the developers and to the security organizations. So if you're an Inspector customer already, then you'll have a very similar experience to what you're used to. You'll go into an Inspector, you'll see the new code security capability there on the left-hand side, and you'll see when it starts to scan your repositories, you'll see your findings appear in the traditional Inspector way. From the developer side, we now have this two-way integration with GitHub and GitLab. And that two-way integration is really the thing that allows us to get closer to the developer workflow. And it provides non-intrusive feedback directly in pull requests. So again, this allows for our developers to not have to move around lots of different consoles, lots of different ways and screens that they have to go and navigate to in order to go and see what's important to them. We can inject that directly into their workflows. This is going to allow us for fast and actionable insights directly in those development cycles that, again, are happening on a pretty regular basis. So let's take a look at what this looks like in action. Okay. Load this up. Let's see if it starts. Okay, so I'm in my Visual Studio Code IDE. I have a number of, I've got infrastructure as code, I've got a number of application files that are mostly Python, and I'm going to commit this up into my GitHub repository. We're then going to take a look at that GitHub repository in a little bit more detail. So this is my GitHub repository. It's a fairly basic Flask application. It's got a whole bunch of application type vulnerabilities, a whole number of infrastructure vulnerabilities. I'm not a very good developer, so this is why everything is so insecure. And so what we're going to do, I'll just pause this for a minute, is we're going to navigate over to Inspector. As you can see on the left-hand side, we have the new code security capabilities. So I'll let Nurali talk us through a little bit of that in more detail.
Yep. If you're familiar with Inspector, we've introduced a new page for code security where you can come in and establish a connection to the source code management platform of choice. Why don't we actually walk down the lane of integrating into GitHub? In this case, I'll go ahead and connect to my GitHub repository. Go ahead and see there has no integrations that exist today. In terms of configuration, nothing's exist. I'll go ahead and connect into GitHub. We also understand that in your workflow, it is important to highlight what's recommended. So as you establish your connection, we'll give you a default configuration that we would recommend, allowing you to scan once a week or once a month. You have an option to change it. Every time your developers may be changing code, pull request, merge request, or push to main across each of the scan types, ISE, SAST, or SCA.
So really importantly here as well, this is our default scan configuration, right? So this is the thing that gets created when you start the initial connection with a GitHub or a GitLab. You can choose to just skip this, right? But what this does is this means that this configuration gets applied to all repositories that are already existing in your GitHub repository. So immediately pull those in and take that as part of the scan configuration. It also means that any new repositories that get created in that, or any new projects that get created in that repository also start to get looped into this. This is our kind of recommended default setup. You can also go ahead and edit this to make it more relevant to you. So examples could be inclusion tags, where you may only want to say, actually, I only want my default scan configuration to be applied for my production or any repositories that are tagged as a production repository. For everything else, we can choose, maybe we create another scan configuration. So there is flexibility there as you go and do this, but that's why we try and do this in our setup flow to make sure you at least have something as a catch-all for all of your repositories.
Moving on, once you create these scan configurations, whether default, edit them at this stage, choose to skip them, you're able to proceed with your integration workflow. Come and give it a name. There is also an application that you need to go and either download and install first in the GitHub Marketplace. If you've already done that, we can port that over. Or real quick, just go ahead and install the new application. Under the hood, you're actually giving it authorization authenticating to the platform, giving it authorization to actually connect and get your code repositories.
So again, this piece is really important, right? You can go ahead and do this setup directly from within your GitHub account, where you can go to the marketplace and download the Amazon Inspector extension directly through there, or we can do this as part of the integration flow. You also have a choice here. You can have the application connect or have the ability to read and write or read all the repositories within your account, or only select ones. That's a decision that you as customers can make. We would probably suggest choosing all, at least that way Inspector has all the visibility. You don't necessarily have to scan them all from the Inspector side, but at least making sure that Inspector has that visibility. And then with the scan configurations, that's where you can choose which ones you really want to be scanning on a more regular basis. And again, permissions-wise, you'll need the ability to set something up that has read to all the repositories, as well as write permissions only to pull requests.
Okay, we've finished the installation of the app, and you will be redirected back to Amazon Inspector to come back and verify. I have a few code repositories. It'll automatically start to discover these repositories based on your settings, and they will all show up in this list within this page, so you know how many are there and what is the scan status. If you remember in the previous setting, I actually did a weekly scan as default. Monday was the day. Today is, I think, Wednesday. So it's going to scan as my upcoming schedule or when your developer makes the change. But why don't we just go ahead and try to scan one right now to see what the findings look like, because you've just discovered these applications, these repositories, the scan status is inactive. We'll pick one of them. We already know that the web app that we have installed is actually vulnerable. We'll go ahead and do a quick scan on them. We're verifying there's been no scan done on it. Here's the particular project ID. It's coming from GitHub in my case, and what is the integration ARN associated with it. I'll go back, select that particular repository, and go ahead and scan it on demand. So in addition to setting up a scan cadence, which is periodic on a weekly or a monthly basis, or at change-based triggers, you certainly can go ahead and scan them at an instant. We run the scan and we see all the findings being generated. I have 6 critical findings in this particular repository or my project. What do they look like? Let's go ahead and dive into the details of one of them. First, let's verify. I actually ran the scan, yes. It was through an on-demand scan, the difference being if it was actually triggered through something that was set up, it'll show up in a different field. It was an on-demand scan, and we'll now go check on the details of the vulnerabilities. If you notice, the details of one of the vulnerability has a public read bucket ACL. It actually have over-permissive settings, which is a vulnerability. The findings look no different than what a typical Amazon Inspector finding has. The details and the overview are all showing up. What are the rules associated with it? When was the finding created? What is vulnerable in that particular finding? We'll even highlight the finding or the line in the code that we detected as vulnerable with access control, and give you an automated generated code fix recommendation. We think you have a public read access. Go ahead and make a change with these recommendations provided to you in the findings. With our code fix recommendations, you're welcome to just take it, give it to your developers, add it, iterate it based on that, and check the code back in. Now looking at another vulnerability as well, in this case, just a sample of how that looks like. There's improper parsing of HTTP requests. It is a package vulnerability, details on when it was created. A package vulnerability will have remediation recommendations. It may not have a code fix recommendation. It may suggest that you upgrade to the latest and greatest version available.
So really importantly to mention as well, as Nirali started to hint earlier, all of these findings, when they come through, they hit EventBridge, right? So if you want, you can get all of your critical findings going straight into EventBridge and then into potentially a SIEM or to some alerting notification. Again, the beauty of EventBridge is you can be very specific about what kind of alerts you want and where. And so again, you can choose a code repository that is critical to you, and you can say every time there is a critical, regardless of how it's been triggered, whether it's an on-demand scan, whether it's a pull request, whether it's a push to main, or whether it's a weekly cadence scan, you want to be alerted of any critical vulnerabilities that come through of your specific important code repositories. And that way, again, you've got that flexibility to be alerted very quickly, and you can send alerts both to your security teams and to your development teams as well.
Okay. Moving on, I think we'll walk you through an example of the scan triggers when the developer changes or adds features.
So what I'm going to do here, I'm going to continue on some very bad development practices, and I'm going to add some additional vulnerable code here. So in this case, I'm adding an S3 bucket that gets created through infrastructure as code, but that S3 bucket allows access from any principal, right? Which essentially means it's a public S3 bucket. To add to that, I'm going to push this directly to a main branch. So when we start to see this, we can see that our vulnerable code is there at the top. I'm just going to go ahead and push this directly into my main branch. I'm going to hope that this isn't a production workload, because that's very bad practice. What we then see here is we now see that one of our repositories has now become active. Why has it become active? Because one of our triggers in our default scan configuration was a Git-based trigger, which is a push to the main branch. So every time I'm doing some bad development practices and I'm pushing to the main branch, this is going to pick that up and it's going to run a scan for us. So we can see here now that our scan status has changed for our vulnerable web app, and we can see that it's active, and we can see more details around the last scan. So we can see here really important metadata as well. Last main scan was about 3 minutes ago. The last on-demand scan that I triggered before was 23 minutes ago. Again, importantly, extra additional detail here is around the commit ID. So I now get the exact specific commit ID that was scanned, so then I can map specific findings that has come from the scan to my commit. And again, what I can do now is I can just sort this by age, and what we'll see in here is we've got a new finding, which is the restrict actions with any principal for S3 buckets. We can go in here, we can see it's a code vulnerability. We have some specific detector tags as well, and what that means is where we are pulling this in. Let me just rewind for a second. Our detector tags are really important because we are using a set of rule-based detectors, and you can actually go ahead and look at the different detectors that we have on our web page, and you can see exactly what's being pulled out from that. So you can see that in this case, it's a specific AWS Terraform tag and a security tag as well. We have different types of detectors around code quality as well for some other things, but in this case, this one's a specific security one for Terraform. We can see, again, the vulnerability location. So this is the vulnerable 15 lines of code that I've created, and then it will also give us some additional code, some code suggestions. And then the final flow that we will talk about is a pull request. So again, I've got some application code here, some Python code that we're going to load that up. What that means is it's going to give us some essentially remote code execution privileges if that gets abused. I'm also adding access keys. I'm hard coding access keys. Again, big no-no. I should definitely go on some developer training on secure best practices. I've now raised a pull request, at least into my development branch. I can go into my workflow, go into GitHub. I can take a look at that. I'll just say, yeah, this looks good. I'm happy with all of this pretty insecure code, and create that pull request. Now, what we'll see here very quickly is our integration now with the Amazon Inspector app in GitHub. So within a few minutes, it will start to add some comments into our pull request. I'm reviewing the pull request for specific vulnerabilities. I'll get back to you when I'm done, and then it will start to add and nest additional comments in there for the specific lines of code that is picked up as part of that pull request that are vulnerable. So in this case, we see my hard-coded credentials, and then we see further down that we have the vulnerable Python application that I've also written, which is giving us some specific kind of very potentially high permissions to all system users. Again, that could potentially be used as part of a remote code execution type attack. And so that's it, right? So we can see here the difference between kind of the security flow, where the security teams, we expect them to be in the inspector console, and also the development flow. Thanks. Great. So we've seen the demo in action. Let's recap some of the key capabilities of Amazon Inspector Code Security. We can help you scan the code across the entire stack, right? We know, again, that our application is made up of infrastructure. It's made up of application code. It's made up of IAM policies. It's made up of networking stacks. So being able to scan that entire code is super important, so giving you complete visibility into the security issues across that. We're also flagging vulnerable dependencies. As we saw again in the demo, we can flag package vulnerabilities across different types of packages, across NPM packages, PyPy packages, and more, in order to look at where you are getting or exposing yourself through your dependencies. Again, we saw earlier the Log4j example. Understanding your dependencies and their security implications is really important in today's development environment. And then last, we help generate those code fixes. Those code fixes are aligned to security best practices, and it's about making sure that that can be easily consumed by the developers. So again, if you're in the inspector console as a security person, you can download that code snippet and you can send it over to your development teams. Or if you're in your pull request, there'll be a new set of code that can get created, and you'll see the diff directly in GitHub, and you can choose whether to add that directly into that file, and then use that as part of the pull request. And so these capabilities are really working together to help you build your applications faster, help them build more securely from code to cloud, right? Remember, faster, more securely, compliant, low friction, high confidence. Those are all the things that the business is telling us that you as customers are telling us that you need to be able to do.
And obviously, each and every one of you are different. Every customer's needs are different, and they need flexibility. I may want to run a weekly scan. I may want to run a monthly scan. I don't want to run a scan every time somebody edits the code, but I want to actually scan it when they check back into the main. So we've given you the flexibility with our code security, as we saw through the demo. You have a way to set up the schedules as your needs are, as you need so as well. You certainly can do these on demand if you needed to, one at a time, or based on events. Gain visibility across your entire code base. Not on a repo for a particular developer, not on a subset of repositories either. With flexible scan policies. And aggregate all your findings in Inspector, all the way from code to cloud. Coverage is also equally important. So we're giving you the flexibility of the languages we actually support through SAST, SCA, and ISC.
So we've seen the capabilities built out on screen, right? From scanning our code across the stack to flagging vulnerable dependencies to generating those code fixes, but also being able to see that as a security perspective across all of our repositories. But it all comes down to this fundamental belief, right? Whenever I talk to customers about application security and how to help the developers improve the output of their code and the security health of their code without additional friction, What we want to do is want to make the secure thing the easy thing. And we truly believe that organizations can and should build secure software at the speed required to build in the cloud. We don't think this is just a nice to have anymore. It can be done with clear security objectives, early risk identification, and the right tools to support your teams, which is going to help you launch on schedule and maintain an appropriately high security bar. Inspector Code Security is going to help make this possible. It's going to help make the secure thing the easy thing, providing the right insights at the right time to the right people in your organization. And we don't want security to be a bottleneck. It should be an enabler for faster and more confident software delivery. So we're back to our iceberg, the metaphor that we started with. And we found for too long that organizations are focused only on what's above the water, the visible vulnerabilities that are running in those workloads. We know that the real risk is underneath that, supporting everything that's running in production. Amy at the keynote spoke about not wanting to slow down innovation. That's something that we hold ourselves to when we are thinking about what do customers need? What are the features, capabilities, and services that customers need in order to continue to be able to deliver at the speed of cloud? And so with Inspector, we're trying to shine a light underneath the surface. We're trying to give you the right tools to see the full iceberg, from code and to compute alike, so that you can navigate safely, more quickly, and avoid any costly collisions. But this isn't just about finding vulnerabilities, right? We don't want to make this a numbers game. It's about bridging the gap between the development organizations, the development teams, the engine of our business, and the security to help you innovate confidently, innovate at low risk, and take the right risks, and giving security leaders the visibility and they need in order to help with those risk-based decisions. So we want to turn vulnerability management from a typically reactive numbers game or numbers-driven process into a more proactive, seamless part of the software lifecycle.
What next? Go ahead and take advantage of the 15-day free trial that's available for Amazon Inspector. Connect your repositories and go ahead and understand where your vulnerabilities are. Work with your developers to actually raise your security bar. And start scanning your code today with us. Here are some of the useful resources that you can actually start leveraging now. Documentation, our blog, as well as the demo video are all available here.
All right. Thank you very much. This is APS203. Thank you for coming. Enjoy the rest of Reinforce.
Thank you.